Hello everybody, I'm Nick, and in this video I'm going to show you one of my favorite features of one of my favorite databases, and that is AWS DynamoDB. Now, in case you don't know, AWS is the cloud platform I am using in my professional life, and DynamoDB has a very special place in my heart because it's a database that is very fun to work with because data modeling for DynamoDB is awesome. On top of that, it has some very nice features like the one I'm going to talk about today that really helps you streamline your architecture. So even if you don't use AWS or DynamoDB, this will help you rethink your architecture, especially in a more event-driven way. Before I move on, I should let you know that this video is sponsored by AWS, and anything you see me using in this video is part of their free tier. You can click the link in the description to get started with AWS completely for free. If you like the type of content and you want to see more, make sure you subscribe, ring the notification bell, and for more training, check out nickchapsas.com. Now, any code you see me using or writing in this video is publicly available on my GitHub account. Since this video is sponsored by AWS, I don't have to put the source code behind a Patreon paywall, so click that link in the description if you want to get access to the code. So let me show you what I have here first. So I have a simple product catalog API. And before I show you the code, I'm going to go straight ahead and I'm going to run this. So I'm going to hit the debug button and I'm going to go to my Postman account. And all I can do is I can get a product by ID, I can create a product, I can update a product, and I can delete a product. Very basic REST API type of microservice. And this is how I would create, for example, a hoodie. I would say that the product name here is hoodie, the description is a really cool hoodie, and then the price is this, and it is in GBP. And I can go ahead and I can create that product. So as you can see, this product was created. I'm going to grab the ID here and I can go on the get page and hit that. And as you can see, I'm getting that product by ID. This is now created in a DynamoDB that lives somewhere in the cloud. Then I could update that product if I wanted to. I can use the ID here and say a really cool hoodie and update the price as well. And if I do that, this is now updated and I can go here in the end and delete it. So it's a fully functional CRUD API using DynamoDB. So let me run you quickly through the code. I have my controller here, the product controller, which can get an item by ID and calls a service. It does some contract mapping. We have contracts both from the API to our domain model and from our DTOs to our domain model. We're calling all the way down from a service into a repository, which is over here, and it uses an Amazon DynamoDB client to connect to DynamoDB and retrieve the data back. In terms of keys, we're using a partition key and a sort key. They're both pointing at the same value, and that is a product hash and the product ID. We're using the same value because the uniqueness of an item in a table in DynamoDB is actually a combination of the partition key and the sort key, meaning that you can actually have many things with the same partition key as long as they have different sort keys. This will become way more clear when we go into the console and I show you what's going on there. But this is a very basic setup, ensuring that our application will scale because the product ID is randomized. It is actually just a GUID that would lead in very even partitions across our DynamoDB table. Now let's see what's happening on the AWS console. So this is our landing page. I can go into DynamoDB. I can list my tables over here. And this is the table I'm using. It's called items. In terms of partition key and sort key, I'm using PK and SK intentionally. I am naming my properties in my DTO PK and SK because it is generally a good practice to actually group different types of entities together in a single table. Dynamo is very good at handling that as long as your data modeling is good. You certainly don't need one table per specific type of item. There might be scenarios where you might want to consider that, but I'm going to mention why that might be the case as we go. But for now, this is a very simple table setup. It's using the maximum amount of read and write units that are still free in AWS, and that is 25 for reads and 4 writes. And if I go into explore table items, I can run a query against the table. As you can see, now we have nothing. But if I run this API and I quickly just create an item just to show you, here we go. Let's go ahead and fire that request. It's created. Then I can go here, run, and I can get my item here. And it's visualized either in this way or as a JSON object like that. S means string, N means number, and then you can have SS and so on and so forth. It is the way Dynamo is modeling its object. you can actually turn this off and see a flat JSON format as well if you want by clicking this button. Now, in order for you to understand what problem I'm trying to solve in this video and why I'm going to use the feature that I will use, let's take a look at the whiteboard and do a bit of an architecture diagram. So let's take a look at what we have here. First, we have someone, let's say it is me, and we have this product API here. So API goes here, and I can call this API, and this API will call DynamoDB over here, DDB, to get the data. So our product data is in this items table, and we call it, we create stuff and we read stuff. And that is fine. However, DynamoDB works on a credit-based system. So as long as you have enough units, you can read and write, but as your traffic becomes more intense, you have to scale to more units to keep up with the traffic. This is great, and actually DynamoDB is very good at also auto-scaling with your application's demand. However, sometimes it might make sense for you to put a caching layer between DynamoDB and your application. In most cases, that would be a Redis cache. So what would happen, and let's just put Redis here with this R, is a user will come in, say, give me a product with this ID. The API would look into Redis, and if the product was actually cached in Redis, it would directly be returned here and never hit DynamoDB. However, it could also be that the product is not there, and then we have to call DynamoDB. And maybe on the way back, we actually also cache it into Redis. This is one approach. Another approach would be that as things are created, not only do you save it in DynamoDB, but you also cache them in Redis. And that is maybe fine, but I'm not a fan of the idea that when you create something, it has to be atomically written both in DynamoDB and also in Redis, and you have to worry about retries and fails to connect to Redis, or maybe your write to Dynamo succeeds, but your write to Redis fails. So when you have to make two calls to two different data stores for one request and ensure that both of them work, even though you can't really atomically ensure that both of them did work, then it becomes a bit complicated. What I've also seen around is that some people prefer to do the following. They prefer to save into DynamoDB, and they also push into something like an SQS queue. And then that SQS queue has maybe a Lambda or a consumer, which is eventually what synchronizes the cache into a Redis cluster, and then you're making that Redis call here. There's so many ways to deal with this. However, my absolute favorite, and the one I'm going to show you how to implement in this video, goes as follows. Instead of having to make two calls when you create something here, what you can do is use DynamoDB's Streams feature. And what happens is you can enable actually streams here, and streams are effectively a log of all the actions that took place in DynamoDB, that is creations, updates, and deletions. So you can actually enable that stream, that is just all the events that happen in DynamoDB, and this is automatic in DynamoDB, it's not a separate service, and then that stream can be listened to and triggered when things change in the database using a Lambda. A Lambda is just a function. It's a very short piece of code that runs somewhere on the cloud, and you don't have to worry about it. It is serverless. It will scale, it will deal with the traffic, and yes, you can configure some things as well, but fundamentally it is a very simple unit of code that just runs somewhere. And that's what eventually will push the thing into Redis. And then you don't have to make two calls from the API. Your API stays very, very fast. And this is a nice event-driven approach where things move from here to here to here and then back into here. It's very, very elegant. Let's dive straight into the code and see how we can implement this in our API. So we need two things. We need the Dynamo streams to be enabled, and we need a Lambda. I'm going to start with the Lambda side of things because it's actually ridiculously simple. First and foremost, we need to install a CLI tool, which will make our life so much easier. So all you need to do is say .NET tool install G, stands for global, Amazon Lambda tools. And that's it. This globally installed Lambda tooling in our machine. The next thing I need is to install the AWS templates. So when I go here to create my Lambda project, I will be able to see some really nice templates provided by AWS. To do that, all I need to say is .NET new I Amazon Lambda templates. And that's it. This will now find and install, as you can see, all of these AWS related templates. And that's it. Now I can go here and create my Lambda. Remember, the Lambda is what will listen to the DynamoDB stream. So the changes as they happen, for example, item created, item updated, or item deleted, take that document and synchronize it into the cache or remove it from the cache when an item was deleted in a very nice event-driven approach. So we can go in the source folder and say new project, and we can actually find, if we search here, the Lambda simple DynamoDB function. I would recommend against using that because this would use .NET Core 3.1. What you want to do instead to use .NET 6 is use this one over here, Lambda custom runtime function .NET 6. This will be enough. So I'm going to go ahead and I'm going to call that product catalog cache sync, and that's it. And maybe .lambda to specify that this is a Lambda here. And this will probably also create a test project, which I'm just going to delete. We're not going to talk about unit tests in this video. So let's see what the template comes up with. We have this set of configurations here, which will be used when we push our service into the cloud. Then we have a README with some instructions, very, very helpful. We're actually going to use some of that stuff. And then we have the function itself. And this is the main code where you have a Lambda bootstrap builder here, which points into a handler. And this handler is basically the method that's called by the Lambda in the cloud every time something changes. Now I'm going to delete all that because I don't need it. And I'm going to import some NuGet packages that we're going to need here to act on DynamoDB content. First, I'm going to need the AWS DynamoDB Sdk. So that would be AWS SDK.DynamoDB v2. You can see the name over here. I'm going to click that and install it in the Lambda project. And then we're also going to need the amazon.lambda.dynamodb event. And that's what we're going to use to enable the triggering mechanism where DynamoDB events are hitting this Lambda as they happen. So I'm going to go ahead and install that too. Here we go. And now let's go ahead and implement a few things in the Lambda. So first, this handler should be an async task because we're going to make IO calls here. And it shouldn't have a string as an input. It should have a DynamoDB event. So DynamoDB event. And the Lambda context can be useful here. It gives us access to many parts of the Lambda execution. We're going to use it in this case for the logger, so to write logs as part of the Lambda execution. Now for this to work, we do need to update it to reflect what we're gonna do. So the input here is a DynamoDB event and the output is a task. And now this part is happy. And we're free to implement now our handling. What will happen is this function will be called, and let's just write actually, logger.log line goes here, and we can say beginning handling of DynamoDB updates, document count, and we can specify how many documents we're going to handle. It's going to be DynamoDB records.count goes here. And in the end, we can say something like completed handling documents. That's it. So our main handling will be here. And this is where we're going to write into Redis. Now, I have already created a Redis cluster. Well, it really has one node only, but my Redis is here. As you can see, this is the connection. This is where it's located. And currently it has nothing. I'm using this tool to visualize stuff. Now we're going to be writing into that. Now, since we're going to be writing into Redis, we need to create a Redis connection here. And what I'm going to do is I'm going to add the stackexchange.redis package, which allows us to access Redis in a very nice way and do operations against it. So that is now added. And I can say private static iConnection multiplexer, which is how we can connect to Redis. So we have the multiplexer here, and we can start it in the main method here. So we can say connection multiplexer equals connection multiplexer dot connect async. So we can await this, and we can grab the connection string from an environment variable. So we can say private read only string Redis connection string, and that can be loaded by environment dot get environment variable, and all we need to provide is the environment variable name. In our case, it can just be Redis connection string, and we're gonna set it up in the cloud in a second. And all we need to do is just pass this down and maybe just make sure this is static too. That's it. It doesn't need to change during the runtime. So we're all good. And now we have the multiplexer, which gives us access to the database, and we can start adding keys. So since the DynamoDB event has a bunch of records in it, we need to loop around them. So we can say dynamodb.records, and then this is just a DynamoDB. I'm not going to say stream record, just DynamoDB record. That's it. Now, each record individually can have a different action in it, meaning it could have been created, updated, or deleted. And this is on an individual level. This Lambda, we are going to configure it to be triggered in a batched fashion. So it's not going to be triggered once per document update. If a bunch of them happened at around the same time, they will all be batched, and this will be more efficient for our application because less Lambda executions will happen. So what I care about is, first and foremost, was this deleted? If it was deleted, then delete it from the Redis cache. We don't need to have things cached that don't exist anymore in our product catalog database. So we can say DynamoDB record.event name is remove. So if this was actually removed, and let's say continue in the end, and all we need is to get the deleted item ID. So deleted ID is DynamoDB record.dynamodb.old image. And this is very important. Stream allows us, if we want to get both the old image and the new image, meaning the item before it was deleted or edited and the new version. So if you're updating and you only want to update the cache on specific properties, you can actually compare the old image and the new image, meaning the old version of the document and the new version, and only conditionally act on it. This is very, very nice. So we have that, and we want the ID field, so we can get it as a string. Here we go. And we can simply say await connection multiplexer. And in fact, we can actually move the database up here. We don't need to get it every single time. So connection multiplexer.get database goes here. This will default to the first one, and say await database.key delete async. So delete something by a key value, and that is deleted ID. That's it. And now we can do the update and the create. In our case, they're both set mechanisms, so it doesn't matter if you updated or created it, we will just gonna set the value. And the way to do that might look a bit clunky. We first have to get the attribute map, convert it into a document, convert it into JSON, and then save it as a string. So var record as document equals document.from attribute map is what we want. And we want the new image. So DynamoDB record.dynamodb.new image. Here we go. Then JSON equals record as document to JSON. And then we can grab the ID of that document using the same mechanism. So just say ID here. And of course, this is the new image. And finally, we're going to set it. So database.string set async, and we're going to set the ID and then the JSON. And that's it. The item we're going to cache is the JSON object. And in terms of code for the Lambda, that's it. We have a fully serverless Lambda that you can just deploy, and don't worry about it. AWS will do the rest for us. Let me show you how you can deploy it. It is extremely easy. So first, we're going to cd into our project directory. And by the way, just so you can see it, if I go into my Lambdas over here, as you can see, I have nothing. There are no functions here. So all I need to do is say .NET Lambda deploy function, and I'm going to use, how do I call this? Product catalog cache sync. I'm going to call it that. So here we go. I'm just going to press enter, and this will do the rest for me. It's going to build it, it's going to package it, and it is going to deploy it. It's going to ask me a couple of questions, mainly around roles, and I'm going to answer them. But that's it. Look, it's doing everything up for me. It's zipping it up for me. I have a previous role here from when I was doing this, when I was preparing for the video. But for the sake of this video, I'm going to actually create a new IAM role, and I got to give it a name. So how do they call the project? Product catalog cache sync _ role. It goes here. And then as you can see over here, I am asked to select an IAM policy to attach to this new role and grant permissions, because the Lambda will need access, in our case, to DynamoDB to act on it. I think that this over here, the AWS Lambda DynamoDB execution role, which as it explains, provides list and read access to DynamoDB streams, and it's cut off, but this should be enough. We might also need this one over here, the VPC access execution role, but let's see. I'm going to start with 2. And as you can see now, this is creating the IAM role, and it is propagating to the appropriate regions. So let's wait for a second and see what happens. So that's it. The Lambda is created. Let's go back into the UI and see what we have. So if I refresh that, as you can see, our Lambda exists. Now for this to actually work, I need to do a couple of things. First, in the configuration, I need to go to the permissions and find the role, and go to the IAM role and attach an extra policy. And that is the AWS Lambda VPC access execution role. So I'm going to attach that. Here we go. And now I should be able to go to the VPC section over here and select the VPC I have for this to actually be able to access my Redis cache, which I run in my own EC2 instance. You could run Elastic Cache as well, but it would be hard for me to connect locally and run this locally against Elastic Cache. Realistically, everything will just run into the cloud and the cloud itself will be authorized to act on it. So this is now updating the function, as you can see here. While this is happening, I can go to the configuration and environment variables, and I can add my connection string, the one I created for the Redis cache connection string, in here. So all I need is copy that key and paste it here. And then my connection string, I can just grab it from my Redis UI tool here. I'll paste that, and then the port is 6379 and save it. So now this is saved over here. That's it. And now that this has completed, I can go here and create an alias for my Lambda. I'm just going to say first release here. This can be used for many reasons. I'm going to point to the latest version of the code and create it, but we need this for the trigger to work. And now with all that Lambda stuff configured, I'm going to go back to the console and I'm going to select DynamoDB here. We're going to find our table and we need to enable the DynamoDB stream. By default, it is not enabled. So I'm going to click on exports and streams and I'm going to select enable DynamoDB stream here. So we need new and old images. So both the item before it was changed and after it was changed. I'm going to enable the stream and that's it. This will take just a second. Actually, it's already created and I can go into the Lambda in the configuration and I can choose add trigger. And I can say here, DynamoDB. As you can see, there's a bunch of things I can create a trigger on, an alert on, even logs, event bridge, kinesis, MQ, so many things. All we need to do here is just say DynamoDB, and that's it. And we can point to a table. For us, it is this items table. The batch size is how many records will be batched in a single execution. And you can configure other things like the batch window and the starting position, and some other stuff that I'm not going to talk about in this video because they're a bit more advanced. But with all that, I'm going to say add, and now this is now added into my Lambda, as you can see here. And if I go back into the DynamoDB table and I refresh, as you can see, this is now added here. The trigger is wired up. So with all that configured, I think we're ready to actually run this. Let's go here and run the API and then go to Postman. And what we want is, as you can see here, our Redis server is actually empty. So what we want is when we hit create here and we go back to Redis cache and I refresh, as you can see, this has been added here because the stream triggered the Lambda and the Lambda added this into the cache. So what's left for us is actually write something in that repository code to read from that cache when that value exists. Now, since I already talked about the Redis cache code in this video, I'm going to fast forward that part and just show you the end result. But it's still a connection multiplexer, a get and a set on the key. So I've updated the code. As you can see now, we're injecting that multiplexer in the repository. We're checking the Redis cache first. If the product exists in the cache, we just deserialize it and we return the DTO back to the user. If it does not exist in the cache, we go to DynamoDB and we actually put it back in the cache to if it exists. So let's run a full check here. I'm going to run this API now. And what I'll do is I'm going to open the Redis cache and see there's only this one document we created. Let's just delete it, in fact. So delete it here. And I'm going to go and create a new hoodie here. So hoodie created. Let's try and get the hoodie. And what I want to show you here is I'm going to debug this code. I'm going to put a breakpoint and I'm going to run this call. And as you can see, we hit the breakpoint, we make the connection. The product actually exists. As you can see here, you can see actually the text when I hover. This is retrieved by Redis and it actually looks like this. And then we can remove this and return it. Now it is coming from the cache and it's super fast and it costs us less than calling DynamoDB directly. Then if we decide that, hey, I want to delete this, I'm going to go ahead and I'm going to just delete it. And because we delete it in DynamoDB, the Lambda will be triggered and the value will be removed from the cache, as you can see here, automatically. It's a really nice event-driven setup that can take you a long way, and you can actually take it in any direction you want. You might not want to go directly into a Lambda. You might want to put kinesis in the middle and then fan the updates out to multiple consumers, maybe play with event sourcing a bit and maybe publish those changes as events to your consumers. There's so many things you can do. I really like this feature. Again, You can try all of this for free. Click the link in the description. And if you want access to the code you just saw in this video, it will be down below too. Well, that's all I had for you for this video. Thank you very much for watching. Special thanks to my Patreons for making these videos possible. If you want to support me as well, you're going to find a link in the description down below. Leave a like if you like this video, subscribe, more content like this, and ring the bell as well. And I'll see you in the next video. Keep coding.